Hello, mathematicians. We are going to start section 2.4, and section 2.4 is all about infinite limits, just meaning that when you're taking the limit as x approaches a of f of x, you're getting infinity or negative infinity. Okay, so that's what we're talking about here with these infinite limits. Let me focus. There we go. That's better. So let's go ahead and do an example. And let's look at the limit as x approaches 0 from the right-hand side of 1 over x squared. And we'll look at the limit as x approaches from the left-hand side also. And so let's just draw this graphically so that we have an idea of what it looks like. It'll help us with our understanding and intuition. And so we know that this looks like the graph of f equals 1 over x squared. So it's going on in orange here. Label it. F of x equals 1 over x squared. That's going to be really smudgy. I'm going to regret writing in that pen later. You hear weird noises in the background. That's my cat playing with a paper bag right now. Okay, and so what's going on here? Let's find a place on here just to label 1, right? So at x equals 1, we'll get an output of 1 over 1 squared. So this is the 1. Right? And so this then on the other side up here. Negative 1, 1. Okay, and as x gets large, all right, as x gets large, right, we're getting closer and closer to 0. F of x gets closer to 0. Right, and over here, the same thing. As x gets really small or very large negative, right? Your f of x goes to 0, right? But in between 0 and 1, in this area here, these are already fractions, right? And so let's go ahead and make a table real quick of what happens between x equals 0 and x equals 1. Okay, that's the space that is going to go to infinity, right? And so let's just make sure that we illustrate why. So we have x, here's my output, f of x. And so when x equals 1 or negative 1, right, our output is 1, right? Because we get 1 over 1 squared. If x is 1/2, we get 1 over 1/2 squared, which is equivalent to 1 over 1/4, which equals 4. So we input 1/2, which is less than 1, and we got an output of 4. Now, if I go ahead and put in something like 1/10, which is now even smaller than 1/2, and I have 1 over 1/10 squared, you get 1 over 1/100th, which equals 100. So it seems the smaller I get, the larger my output is. Right? I put in 1 over 100. I get 1 over 100 squared equals 1 over 10,000. I get 10,000 out. Okay, so as we get smaller and smaller, as we get closer and closer to the 0 here on the x-axis, this is my x, this is my y, this output goes all the way up to infinity. Okay, so graphically, we can see that the limit as we approach 0 from the right-hand side of 1 over x squared, right? As we travel this way on the x-axis, we see the output here is going to keep going up, 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 up. And we can see that looking at this estimate, right? As we keep getting closer and closer and closer, we can look at this trend and see where we're going. We can also just plug this in. And 1 over 0 is going to equal infinity. Remember, we're not actually getting to 0. We're approaching 0. Right? And anything over 0 is going to infinity, or negative infinity if it's negative. Okay, let's go ahead. And if we look at the left-hand side, we have the same thing. As we're approaching 0 from the left here, we see that we're getting higher and higher and higher. If I were to go ahead and plug in -1, I would get the same answer here, 1. -1/2, because I would square it here, right? You'd get 4. So it's symmetric, we know, around the y-axis. And so we know that this also goes to infinity. Therefore, the limit as x approaches 0 of 1 over x squared equals infinity. I should say therefore. Okay, let's do another one real quick. Why didn't I do the example, the limit as x approaches 0 of 1 over x? Let's go ahead and look at the graph of that. So this would be example 1. Let's do example 2. What does this graph look like? And then maybe like this, something like that. Here's my x, here's my y. My functions in orange. Okay, and so I'm going to go ahead and look as we go to 0 from the right-hand side. And I'm going to go ahead and look as we go to 0 from the left-hand side. And so graphically, we can clearly see that here this is headed to negative infinity. And here this is headed to positive infinity. So graphically, we can see that we're not headed to the same place as we approach 0 from the right and from the left. As I travel in this direction, I am not ending up in the same place as I do if I travel from that direction. Now, algebraically, to do this, what I can say is here, I'm putting in, I'm going to go ahead and say, I'm even going to put a 0 from the right-hand side. Okay, so that's going to go ahead, and that's going to go to my positive infinity. Over here, this is going to be a negative number down here, right? It's going to be like negative 0.000001 or something smaller or smaller. But this side is going to be negative. It is plummeting towards negative infinity. Do you see that? It's different because up here we squared it, and because we squared it, it was still going to positive infinity, right? But this is going to negative infinity. So this one, I'm going to just remind myself here that, oh yeah, it's coming from the left-hand side. That's going to be a negative number, negative infinity. So therefore, the limit, there should be another e in there, of 1 over x as x approaches 0 what am I going to put here? Therefore what? Does not exist because the limit as x approaches 0 from the left of 1 over x does not equal the limit as x approaches 0 from the right of 1 over x. Okay, so I'm going to stop this video because it's gotten long enough, and then I'm going to do another video and just do some more example problems.